Hello and welcome. In this video we are going to look at atomic structure. We are going to see some of the basic concepts of this topic. We shall look at isotopes, we shall look at mass numbers, the structure of an atom, and we shall attempt some few questions. So currently the atomic structure is of this format. We believe that an atom is made up of mainly two regions. One, which is the nucleus, usually found at the center, and it's a very small portion of the overall structure of an atom, occupying less than 20% of an atom. So this nucleus, just like in biology, it's very vital, and in our case it will have two subatomic particles. If our atom is a particle, then it's made up of subatomic particles, smaller particles, and they are mainly three in number. We have the protons, neutrons, and electrons. The protons and neutrons are found in the nucleus. So this nucleus here, we have the protons and neutrons in the center of the atom. Protons are positively charged, while neutrons have no charge. So that means their charge is zero, if at all we would like to say they are charged. Our electrons are negatively charged. That means electrons and protons probably attract one another. So electrons are not found in this region here, the nucleus. However, they are found around the nucleus. They are normally in motion, moving around, usually in circular motions, but not as exactly circular, but they are always evolving around the nucleus. So if you look at these electrons, we have always regions around this nucleus where we have higher chances of finding them. These dotted lines are showing these regions. For example, this electron can be found anywhere in this region here. So this region here is known as the energy level, or the energy shells, basically because they have different energies. So this energy level here, we can have electrons there, and this energy level we can call it the first energy level, n is equal to 1. The one next to our nucleus is the first energy level, while the second one will be energy level 2, n is equal to 2. We can have up to 7 energy levels. So basically the structure of an atom, it's made up of the nucleus where we have protons and neutrons in the center, and it has electrons moving around the nucleus. So one thing to know about an atom has no overall charge. Yes, it has charged particles, the protons and electrons, but all together the number of protons are always equal to the number of electrons. And because the charges are somehow similar, basically they will cancel out. So if you have equal number of protons and equal number of electrons, these positive and negative charges will tend to cancel out. So an atom, we can say it's electrically neutral. It has no charge. It's electrically neutral. Yes, that's all about the structure of an atom. So if we look at ways we can describe an atom, we normally use a term known as atomic number. Atomic number is a number specific to a specific element. Not two elements can have the same atomic number. What do I mean by that? When you look at an atom that has one proton, we shall say that atom is hydrogen. Hydrogen has atomic number 1. If an atom has 11 protons, atomic number 11, we shall say that that atom is for sodium, meaning it's a sodium element present, if at all we are looking at that atom. If we are looking at carbon, carbon has 6 protons. So if you find a particle that has 6 protons in terms of an atom, that means that atom is for carbon. So the atomic number will be always what defines an element. And this is the number of protons in the nucleus of an atom. Probably that's why we said they are found in the nucleus, because it's very vital. It's the building block for a given element. So they are usually represented by this letter here, capital Z or capital Z. There's no reason why they chose Z, but it is what it is. Z represents atomic number. Now we also have mass number. Mass number has a symbol capital A. Probably this could have been for atomic number, but they chose capital A for mass number. Just like the name suggests, mass It's due to the particles that tend to provide the biggest mass for that atom. When you look at the three subatomic particles, the protons, the neutrons, and the electrons, these two have some significant mass. An atom alone is very, very small. That means the subatomic particles, the protons and neutrons, their masses are far smaller than an atom. Now, if an electron has a mass almost 2000 times smaller than a proton, if you have to divide the mass of a proton, we shall find that an electron is far, far smaller. And as such, we shall tend to assume for now that the mass of an electron is 0. So you'll find that for any atom, the mass of that atom will mainly be as a result of the number of protons and the number of neutrons. That's why we shall say that our mass number is the number of protons and neutrons added together. So mass number and atomic number, we can put them together and come up with an expression that can help us relate mass number and atomic number. So mass number, protons and neutrons, is equal to the number of protons, which is P, plus the number of neutrons, N. We can use small n for neutrons. So we can use this relationship to find any missing value that we need. If at all we want number of neutrons and they have given us A and Z, that means we can find the number of neutrons, as we shall see in some of the examples we might look at. Now, it's possible for these small particles, the atoms, to have the same atomic number but different number of neutrons. Remember, I didn't mention the use of neutrons. Man believes neutrons basically try to provide stability of the nucleus. Remember, the nucleus is made up of protons and neutrons. So if you have very many positive charges in a very small space, they will tend to repel one another. So we believe these neutrons are present to somehow keep these protons intact. But what exactly are isotopes? Now you might have heard about carbon dating. In carbon dating, we use a specific kind of carbon atom known as carbon-14. The most common atom of carbon is carbon-12. Carbon has atomic number 6. That means this atom here has atomic number 6 together with this atom here. It also has 6. So that means these two atoms, carbon-14 and carbon-12, are isotopes because they have the same atomic number 6, but they have different mass numbers, 12 and 14. And how is that possible? It's because they will have different number of neutrons. This carbon-14 will have 6 protons and actually 8 will have 8 neutrons, while our carbon-12 will have 6 protons and 6 neutrons. So the difference is basically in the number of neutrons, 8 to 6. So we shall say one element may have more than one type of atom. Like this carbon, it has 6. It has carbon-12 and carbon-14. These are two different atoms of the same element. So some other elements that can have different isotopes, we can have hydrogen and chlorine. It's actually true that most elements have isotopes, but the isotopes of most elements are not stable. That's why we shall mainly stick to some of these few: carbon, hydrogen, chlorine. So feel free to let me know which isotopes do you think does carbon have and chlorine. For example, our carbon has carbon-12 and carbon-14 isotopes. What do you think, hydrogen and chlorine? Let me know in the comment section below. At least we know one of them is found in the sun. So another way of representing an atom is through this symbolic representation. Usually in chemistry, we try to shorten our work by using a short form of this kind, where X is the symbol of the element, A is the mass number, and Z is the atomic number. Let's have a look at sodium and see how we can represent sodium in this format. So sodium, we all know that the symbol, which is our X, the symbol of sodium is Na. So to the left of this symbol, we shall have to write the mass number. Mass number is 23 from the periodic table. You don't need to cram it. And here down, we shall write our atomic number of sodium, which is 11. So this will be the atomic representation of our sodium. So just like you had seen in the previous slide, we had seen carbon 14 of this sort. So when you write something like this, one should be able to tell the number of protons, the number of neutrons by subtracting, the electronic configuration, the group, the period, and so on. So there is a lot of information in something of this nature. When someone writes an atom like this, there is a lot to find out about that given atom. So lastly, we have electronic configuration, basically how electrons are arranged around the nucleus. We know that electrons are always evolving in these energy levels, and the first energy level has the maximum number of electrons being 2, it can always accommodate. The second has a maximum of 8, the third has a maximum of 18, although we shall see some exception to that rule. So different atoms will always have different energy levels, but each energy level can have a specific maximum number of electrons. So when filling in, we start with the first energy level, the one next to the nucleus. And that first energy level always takes a maximum of 2 electrons. The second energy level also takes a maximum of 2 electrons. We usually use the formula 2n squared to help us know how many electrons can be present in a given energy level. So for the first 2, 1 squared is 2. For the second 2 squared, 2 times 4 is 8. For the third 2, 3 squared will be 18. However, for the third energy level, at this level, we shall try to basically stick to 8, because there is some degree of stability that is noted when 8 electrons are present in the third energy level. So for now, we shall be writing our electronic configurations in this format: 2, 8, 1. We can also write it as 2, 8, 1, or we can set 2 to 8 to 1. So feel free to use any of those, or you can inquire from your teacher to see which one they prefer. So let's look at some few questions and try to apply what we have tried to summarize under this topic of atomic structure. So the number of electrons, protons, and neutrons in atoms A, B, C, and D are shown below. They want us to determine the value of X. So X is under the atom of D, if you look at this row here. So one thing to note about any atom, we had said that actually atoms, they always have equal number of electrons and protons. So if we know that the number of electrons is equal to the number of protons, that means we can find the value of X. If you are to see here 8, 8, 16, 16, these are equal. So what does that mean? That means our 3 will also be equal to this X. So our X becomes 3. Determine the approximate relative atomic mass of C. So relative atomic mass is almost the same as our mass number. If you have to remember the mass number, which was represented by capital A, if I'm to remember very well. So mass number is basically the sum of protons and neutrons. So we just have to add the number of protons and neutrons of C. So our C has 13 protons and 14 neutrons, giving a total of 27 as the relative atomic mass of C. Part B, the electronic configurations of the atoms and ions. So A, for us to determine the electronic configuration, we need to know the number of electrons this atom has. This atom has 8 protons as the atomic number. That means it also has 8 electrons. First energy level will take 2. The second will take the remaining electrons, which is 6. So this is the total of 8 electrons. Let's first look at Roman 3, our C. C has 13 electrons and 13 protons, so electron configuration will become 2, 8, 3. 2 plus 8 is 10, 8 plus 3 is 13. So now let's look at the ions. So these are charged, so these are no longer atoms, they are actually ions. So initially, our atom A had 8 protons and 8 electrons. What does that mean by it having 2 extra negative charges? It means it must have gained 2 extra electrons to make a total of 10 electrons. 8 plus 2 is 10, such that the overall charge now, if you have 8 positive charges and 10 negative charges, you'll have an extra 2 negative charges. So we shall have 2 extra electrons. So our ion of A actually has 10 electrons. So electronic configuration becomes 2, 8, such that the sum is now 10 instead of the initial 8. So the same is going to apply for our C3+. It means that our C initially had 13 protons and 13 electrons. But a 3+, it means it has 3 positive charges more. And because atoms cannot lose or gain protons because they are in the nucleus, the best they can do is to lose or gain electrons. And in this case, our C must lose 3 electrons such that the overall charge actually becomes 3+, because it will have 13 protons to the 10 electrons. That's after losing these 3 outermost electrons. So in that case, the new electronic configuration will now become 2, 8, because it also has 10 electrons. Part C states 2 atoms that are of elements in the same group. Now, when you look at the periodic table, as we might have covered it, you'll find that for a given element, the number of electrons it has in the outermost energy level will be the group in which it is. So all we need to do is write the electronic configurations of these 4 atoms and then compare and see which 2 have the same number of electrons in the outermost energy level. So A, electronic configuration is 2, 6. B, it has 16, it will be 2, 8, 6. C has 13, 2, 8, 3. And D, it has 3 electrons, which will be 2, 1. So you'll find that actually among these 4, 2 of them have the same number of electrons in the outermost energy level, which is A and B. So the atoms will be atom A and atom B will be in the same group, which is group 6. So lastly, we have question 2. The atomic number of Q is 13. Write the electronic configuration of Q. So in writing electronic configuration, we are filling in the energy levels. The first energy level will take a maximum of 2 electrons, which is our 2. So that will be completely full. So we shall go to the second energy level. Second energy level can take up to 8. Now that is 10, and the last 3 will go to the third energy level. So that becomes the electronic configuration of Q. To which group? Look at the last energy level. It has 3 electrons, so it will be group 3. You can use Roman numerals. State whether Q would conduct electricity. Now, here we need to know that Q is a metal, a non-metal. And because it has 3 electrons, that means from group 3. And we know that from group 1, group 2, group 3, we are having metals. Metals are from group 1 up to group 3. And because our Q is in group 3, it's a metal. So obviously Q would conduct electricity. Write the formula of the oxide of Q. So the oxide of Q, we need to know the valence of Q first. Q has a valence of 3 because it's in group 3 and it's a metal, while our oxygen has a valence of 2. So if I'm to use our simple method of writing, of coming up with the formula, we shall come up with Q2 from the oxygen O3. Just like our aluminium oxide will be, just that in this case our Al is our Q. So this will be the formula of the oxide, but please don't replace Q with aluminium because we didn't identify it, so you have to maintain it as Q. State the type of bonding in the oxide of Q. So it's a metal, Q is a metal, oxygen is a non-metal. That means Q will lose its 3 electrons to the oxygen atoms, and in that case we are having transfer of electrons. That type of bonding is known as ionic bonding. So feel free to check out my video on chemical bonding if at all you don't know how we come up with this type of bonding. So thanks for watching. Don't forget to subscribe. Let me know in the comment section which videos you would like me to make. However, very soon we are going to start making advanced chemistry videos whereby we shall look at some more complex or challenging topics. Stay safe.